My name is Barros, and here I'm sharing a part of my research about applying data science for the safety of process plants. The truth is, we still need them. They are there, and there's so many applications for them nowadays in the society. But we don't want them to be like this, a source of disaster for human being and for nature. So where all these incidents are coming from? It's coming from mostly human error. What we can do about that? Let me show you some resources of data in chemical engineering field. This is an engineering drawing called Piping and Instrument Diagram, or PNID. It's showing the flow diagram. Please note that this is human readable. Machine is not able to automatically read data from these kind of engineering drawings. One I'm sharing here is another engineering drawing called Mechanical Data Sheet. It's full of data, but still it is just human can read the data from this. And also we have engineering specifications and standards that we have to deal with. Again, they are human readable. It is not possible for a machine to understand except that the machine can do NLP or natural language processing. So how do we design process plants, and how do we decide during the operation or the shutdown maintenance? What we do is we gather all the data, as you can see on the left side. We gather all these engineering drawings, specifications, standards, and we send them to a designer, an engineer, a person in operation field to design or make decisions. So that's a dream. That's what we think that happens, and we want them to protect our planet Earth as well while they're operating. But that's not the reality. The reality is there's so many incidents happening in chemical plants, oil and gas facilities, and that's, as you can see, what happens to human beings and to our nature. This is one example. Happened in Houston. 23 people died, and you can see on the table the amount of money spent for what happened. So what I'm doing here is to gather all the data in something called a knowledge base. This knowledge base in AI and semantic technology field is called ontology. So what I'm doing is gathering all the 3D model, mechanical data sheet, line list, as you can see, and also the human knowledge that it's in the format of human natural language into a knowledge base. This is one example of extracting and converting data from one engineering drawing called PNID to an Excel sheet or any tabular format. From there, we're going to have spreadsheets, tabular format. We are going to have data wrangling because there are so many different terminologies are being used, and we then change that to an ontology. The other part is the natural language. As I mentioned, we have specifications in human natural language. What I do, I use something called controlled natural language, and from there I can change that to ontology. Now, at this stage, we have everything from engineering drawings and natural language in one database called the knowledge base, that we call that ontology. This is one graph database resulted, or something that you actually can see from the ontology. This is just one bonus here. This is not something that we are looking for actually, but this is something, a side effect of having an ontology. Having this, you can do a lot, but this is not the end result. What I'm looking for is the reasoning from the data or from this knowledge base. As you know, for any reasoning, we need logic, and I need to have something called a description logic for that. I know it's probably becoming boring, but just bear with me for another 2 minutes. Expressing our human natural language into description logic is not easy. It's not something that we can do manually. I have shown here 2 examples of that. As you can see, manually changing the syntax, as we know in description logic, is not possible. Here, I'm showing you how we can change the controlled natural language into description logic form. I have used a platform called Fluent Editor, and I can change the controlled English or controlled natural language, have the semantic rules in there, and put it into description logic format using the syntaxes and having the right ontology. This is one example using another platform called Protege. Let me run this. So in this one, you can see that on the left side, I have my engineering drawing, and I have created my knowledge base, and this is the graph database as I have talked about. As you can see, all the edges, all the relations having meanings. It means that, for example, I know an equipment like E1007 is connected to a line. So in our case, connection is actually being defined, so the machine can understand the meaning of the relation and the connection between an equipment and a piping line. That I'm showing here is using Fluent Editor. I have the same PNID as you can see on the right side, and on the left side I have my ontology, but this ontology is actually using controlled natural language. So I have all this information about all parts of my engineering drawing, and I have defined everything in controlled natural language, and I was able to bring in all my information, all my logic that I require to make decisions into Fluent Editor. And what we need from here is to make decisions. So I'm going to have the query or the reasoner, as you can see here, to make decisions. For example, I'm saying, can you tell me if my plant is safe if I have this kind of diagram and it's telling me that it's unsafe because of the information that it has in the knowledge base. This is just a brief description about what I'm doing, part of my research, and the way I'm using data science in that. Thank you very much for your time.